Tornado. With the whirling columns of air reaching from storm clouds to the ground, tornadoes are nature's most violent storms. Born from severe thunderstorms, these ferocious phenomena can obliterate neighborhoods, uproot trees, and hurl vehicles with winds that may exceed 300 miles per hour. One of the deadliest tornadoes in U.S. history was the 2011 Joplin, Missouri tornado, which claimed over 150 lives and causing billions in damages. Efforts to understand the formation and path of tornadoes have led to improved prediction methods. Yet their sudden onset and unpredictable nature continue to pose significant challenges. Tornadoes underscore the importance of emergency preparedness, from individual action plans to community-wide drills, in minimizing the toll on human lives and property. Earthquake. An earthquake is the sudden and often violent shaking of the ground, typically result from the movement of tectonic plates along faults in the Earth's crust. These natural phenomena can occur without warning, causing widespread devastation in mere seconds. The impact of an earthquake can vary greatly depending on its magnitude, depth, and location, as well as the vulnerability of the affected area's infrastructure and buildings. In urban areas, the damage can be catastrophic, with buildings collapsing, roads splitting, and utilities failing, leading to significant loss of life and economic disruption. The 2010 Haiti earthquake is a harrowing example, where hundreds of thousands of lives were lost, and the capital city's infrastructure was decimated, underscoring the critical need for earthquake-resistant construction and early warning systems. Earthquakes can also trigger secondary disasters, such as tsunamis, which we will cover next. The resilience of communities in earthquake-prone regions is continually tested, pushing advancements in technology and disaster preparedness to mitigate future risks. Tsunami. Tsunamis, often triggered by underwater earthquakes, volcanic eruptions, or landslides, are large and powerful sea waves that can travel across entire ocean basins. When these waves reach coastal areas, they can cause catastrophic flooding, destroy infrastructure, and lead to significant loss of life. The 2004 Indian Ocean tsunami, one of the deadliest natural disasters in recorded history, resulted in over 230,000 deaths across 14 countries and caused widespread destruction. Tsunamis demonstrate the interconnectedness of natural phenomena and the global impact a single event can have. They underscore the need for international cooperation in tsunami warning systems and disaster preparedness. Efforts to educate coastal communities about evacuation routes and safety plans are vital in reducing the human toll of future tsunamis. The threat of tsunamis reinforces the importance of understanding Earth's natural systems and the need for vigilant monitoring of seismic activity in vulnerable regions around the world. Landslide. Landslides, the downward movement of rock, earth, or debris along a slope, can be triggered by natural events like heavy rain, earthquakes, volcanic activity, or human activities such as deforestation and improper land use. These disasters can swiftly transform landscapes, burying homes, cutting off roads, and changing the course of rivers. The 2014 Oso landslide in Washington State, USA, tragically demonstrated the destructive power of landslides, causing 43 deaths and destroying an entire community. Landslides highlight the critical importance of land management, early warning systems, and emergency preparedness to mitigate their impact. They also underscore the need for rigorous geological assessments in land use planning to avoid development in high-risk areas. As extreme weather events become more common due to climate change, the risk of landslides is expected to increase, reinforcing the need for comprehensive strategies to reduce vulnerability and enhance resilience in susceptible regions. Mudslide. Mudslides, a specific type of landslide saturated with water, act as nature's unforeseen demolishers, sweeping away everything in their path with a mixture of soil, rock, and water. These rapid flows can occur with little to no warning, especially in areas where the vegetation has been compromised by wildfires, deforestation, or prolonged heavy rainfall. A staggering example occurred in Sierra Leone in 2017, where a mudslide claimed over 1,000 lives and obliterated numerous homes, showcasing the devastating human and material costs. Mudslides reveal the fragile balance between the environment and human habitation, emphasizing the necessity for environmental conservation and strategic urban planning. An astonishing fact about mudslides is their ability to travel at speeds up to 35 miles per hour, fast enough to outrun a car in some situations. Hailstorm. Hailstorms unleash balls of ice from the sky, striking the ground with force enough to damage crops, vehicles, and buildings. These natural phenomena occur during severe thunderstorms, when updrafts lift raindrops into extremely cold areas of the atmosphere, freezing them into chunks of ice before they fall to the ground. One of the most intense hailstorms recorded struck Vivian, South Dakota in 2010, where the largest hailstone in U.S. history, weighing nearly 2 pounds and measuring 8 inches in diameter, was recovered. This event showcases the sheer power of hailstorms and their potential for destruction. One fact about hailstorms is that the energy of a hailstone hitting the ground can be equivalent to a 100 miles per hour fastball thrown by a major league pitcher, highlighting the danger these storms pose to people, livestock, and property. The occurrence of hailstorms emphasizes the need for accurate weather forecasting and effective protective measures for agriculture and property, particularly in regions prone to severe weather. As climate change influences weather patterns, understanding the dynamics of hailstorm formation becomes increasingly important in mitigating their impact. Dust Devil. Dust devils, though smaller and less destructive than their tornado cousins, are fascinating atmospheric phenomena. These swirling columns of air and dust form under sunny, clear skies, typically in arid and semi-arid environments. The process begins when the ground heats up rapidly, causing an updraft of hot air. If conditions are right, this rising air can start to rotate, picking up loose dust and debris, creating a visible vortex. Dust devils range in size from less than a foot to over 10 feet in diameter and can travel across the landscape, causing surprise and sometimes minor damage. Despite their often brief lifespan, they provide valuable insights into atmospheric conditions and wind patterns. Their occurrence emphasizes the dynamic nature of Earth's atmospheric system and the variety of weather phenomena it can produce, even in the absence of significant weather systems. Pest Infestation. Pest infestations, when swarms of insects or rodents overrun an area, can wreak havoc on crops, ecosystems, and human health. These biological invasions often occur suddenly, multiplying rapidly due to favorable conditions such as warm temperatures and abundant food sources. The locust swarms of 2020 across East Africa, for instance, devastated thousands of acres of cropland, threatening food security in a region already vulnerable to hunger. A mind-blowing aspect of locust swarms is their ability to consume the same amount of food in one day as about 10 elephants, 25 camels, or 2,500 people, showcasing their potential for destruction. Pest infestations highlight the delicate balance within ecosystems and the importance of pest management strategies to protect agriculture and biodiversity. Climate change and human activities that alter landscapes can exacerbate the frequency and severity of infestations, underscoring the need for integrated pest management and ecological conservation efforts. Hurricane. Hurricanes, also known as typhoons or cyclones depending on their location, are among the most powerful and destructive weather events on Earth. These tropical storms form over warm ocean waters and are characterized by low-pressure centers, high winds, and heavy rain. When they make landfall, hurricanes can cause immense damage through high winds, storm surges, and flooding. The 2005 Hurricane Katrina in the United States serves as a tragic example of their potential for devastation, claiming over 1,800 lives and causing billions of dollars in damage. Hurricanes not only result in immediate loss of life and destruction of property, but also have long-term effects on the affected region's economies and ecosystems. They highlight the importance of accurate forecasting, emergency preparedness, and resilient infrastructure to mitigate damage. Additionally, as climate change leads to warmer ocean temperatures, the frequency and intensity of hurricanes are expected to increase. emphasizing the need for global efforts in climate mitigation and adaptation strategies. Drought. Droughts, characterized by a prolonged period of deficient rainfall relative to the statistical multi-year average for a region, can have severe impacts on water supply, agriculture, and ecosystems. Unlike other natural disasters, droughts can unfold over months or years, slowly strangling communities and economies. The effects of a drought are widespread, leading to water shortages, crop failure, livestock death, increased fire risk, and eventual food and economic crisis. The 2011 to 2017 California drought, one of the most severe in the state's history, starkly highlighted the vulnerability of modern societies to water scarcity. It forced major cities and agricultural sectors to implement unprecedented water conservation measures and spurred innovations in water management and usage efficiency. Flood. Floods, the most common and widespread of all weather-related natural disasters, arise from the overflowing of water onto land that is normally dry. This overflow can be attributed to several causes, including heavy rainfall, storm surges from hurricanes, melting snow, or the breach of man-made barriers like dams. Floods can devastate communities, destroying homes, crops, and infrastructure, and can lead to loss of life and widespread displacement of populations. No example better shows this than the 1988 Yangtze River floods in China, which claimed thousands of lives and displaced millions of people. Such events underscored the necessity for effective flood management and preparedness strategies, including the construction of flood defenses, the implementation of early warning systems, and the development of community evacuation plans. As climate change increases the frequency and severity of heavy rainfall events, the challenge of managing flood risks becomes more acute, requiring innovative solutions and international cooperation. Polar vortex. The polar vortex is a large area of low pressure and cold air surrounding both of the Earth's poles. Although it always exists near the poles, its effects are most felt during the winter months when it expands, sending cold air southward over the United States, Europe, and Asia. This phenomenon can lead to unusual cold temperatures and severe winter weather conditions in these regions. The polar vortex is driven by a contrast in temperature between the equator and the poles. It weakens during the summer and strengthens in the winter, which can occasionally result in outbreaks of cold air that plunge deep into the mid-latitudes. The 2014 North American cold wave was a notable event linked to the polar vortex, causing record low temperatures across much of the United States. Understanding the dynamics of the polar vortex is crucial for predicting winter weather patterns and preparing for the impacts of extreme cold on energy consumption, transportation, and public health. Volcanic eruption. The spectacle of a volcanic eruption captures the raw power of nature like few other events can. These eruptions occur when there is an increase in internal pressure from the magma trying to surface, leading to the explosive release of gas, ash, and lava. Volcanic eruptions can reshape landscapes, create new landforms, and have profound impacts on climate and ecosystems. The 1980 eruption of Mount St. Helens in the United States demonstrates the potential for destruction, with its massive ash cloud and the lateral blast that flattened forests. Beyond the immediate threat to life and property, volcanic eruptions can have long-term effects on the climate, as ash and sulfur dioxide released into the atmosphere can lead to cooling of the Earth's surface. Preparing for and mitigating the impacts of volcanic eruptions involves monitoring volcanic activity, developing evacuation plans, and understanding the complex interactions between volcanoes and the atmosphere. The study of eruptions is crucial for disaster preparedness and offers insights into the Earth's geology. Sandstorm. Sandstorms, also known as dust storms, envelop landscapes in blankets of fine particles, lifted from the ground by strong winds in arid and semi-arid regions. These towering walls of dust can reduce visibility to zero, making travel hazardous and contaminating air, water, and soil. The phenomenon is not just a feature of desolate deserts, but can impact vast areas, including cities and agricultural lands. The Dust Bowl of the 1930s in the American Great Plains is a historical example of how severe soil erosion coupled with drought led to massive sandstorms, devastating farms and displacing thousands. Sandstorms serve as a stark reminder of the importance of sustainable land management practices and the need to combat desertification. As climate change exacerbates drought conditions in many parts of the world, the frequency and intensity of sandstorms are likely to increase, presenting ongoing challenges for communities and ecosystems. Heat wave. A heat wave is not just a prolonged period of excessively hot weather. It is a silent disaster that can have deadly consequences. These events occur when high-pressure atmospheric conditions trap warm air in an area for an extended time. Heat waves can lead to heat exhaustion, heat stroke, and even death, particularly among the vulnerable populations like the elderly, children, and those with pre-existing health conditions. The 2003 European heat wave, one of the deadliest in recent history, caused tens of thousands of deaths across the continent. It underscored the need for heat action plans, including public cooling centers and health warnings. Heat waves can also strain power grids, agriculture, and water supplies, highlighting the interconnectedness of climate-related challenges. With global temperatures on the rise, heat waves are becoming more frequent and intense, emphasizing the urgent need for climate adaptation strategies and resilient infrastructure to protect communities. Avalanche. Avalanches, the rapid flow of snow down a hill or mountainside, combine the beauty and terror of the natural world. Triggered by factors such as heavy snowfall, temperature fluctuations, or disturbances like human activity, avalanches can bury everything in their path under tons of snow, posing a significant risk to mountain communities and outdoor enthusiasts. The 2012 Tunnel Creek avalanche in the United States resulted in 3 fatalities, highlighting the unpredictable nature of avalanches and the importance of avalanche safety education. What's interesting about avalanches is that they can reach speeds of up to 80 miles per hour within 5 seconds of breaking loose, making escape nearly impossible without proper precautions. Wildfire. Wildfires, uncontrolled infernos that ravage forests, grasslands, and communities, embody the unpredictable and ferocious power of nature. Fueled by dry conditions, high winds, and often human negligence, these flames can consume thousands of acres in a matter of hours. The 2018 Camp Fire in California was one of the deadliest and most destructive, virtually annihilating the town of Paradise and causing numerous fatalities. An astonishing aspect of wildfires is their ability to create their own weather systems, including fire-induced tornadoes, which can exacerbate their spread and intensity. This phenomenon underscores the importance of proactive fire management strategies, such as controlled burns and the maintenance of fire breaks, as well as the need for community awareness and evacuation plans. Thunderstorm. Thunderstorms, with their electrifying displays of lightning and thunder, are common atmospheric events that can unleash a wide range of severe weather phenomena, including torrential rains, high winds, and hail. A single thunderstorm can release the energy equivalent to 20 atomic bombs of the size that devastated Hiroshima. This staggering fact highlights the immense power contained within these natural phenomena. The 1999 Oklahoma tornado outbreak, spawned by a series of thunderstorms, resulted in numerous tornadoes, including one that reached F5 intensity, causing widespread destruction and loss of life. Thunderstorms underscore the necessity for advanced meteorological forecasting and public warning systems to prepare for and mitigate the impacts of the severe weather events they can produce. The development of sophisticated radar and satellite systems has greatly improved the ability to predict thunderstorms and their potential severity, helping to save lives and reduce property damage. Blizzard. Blizzards stand as nature's whiteout, cloaking landscapes in heavy snowfall, fierce winds, and chilling temperatures. These severe snowstorms can immobilize entire regions, disrupting travel, power, and communication lines. The Great Blizzard of 1888 in the United States is remembered for its ferocity, burying cities in the northeast under more than 50 inches of snow and causing over 400 deaths. A blizzard's force can be so intense that it can reduce visibility to zero, making it impossible to navigate even familiar paths. As climate change affects weather patterns, understanding and anticipating blizzards become crucial in safeguarding communities and infrastructure. Sinkhole. Sinkholes, the sudden collapses of the ground swallowing everything above, unveil the hidden voids beneath our feet. Formed by the erosion of soluble rocks such as limestone, these geological phenomena can appear without warning, creating gaping chasms in urban and rural landscapes alike. In 2010, a colossal sinkhole in Guatemala City plunged a 3-story building and a street intersection into the earth, showcasing the dramatic and unpredictable nature of sinkholes. A staggering fact about sinkholes is that the largest discovered, located in China, stretches over 600 feet deep, revealing a hidden force below, a testament to the unexpected marvels sinkholes can unveil. The occurrence of sinkholes underscores the need for geological assessments in urban planning and the development of monitoring techniques to predict and mitigate their impacts. As urbanization increases, so does the significance of understanding the underlying geological risks to ensure the stability and safety of infrastructure in communities. Ice storm. Ice storms, characterized by freezing rain that coats surfaces in ice, transform landscapes into treacherous, glittering worlds. These storms can cause widespread damage, snapping tree limbs, downing power lines, and making travel perilous. The Great Ice Storm of 1988 in North America left millions without power and caused billions in damages, illustrating the disruptive power of these frozen deluges. One less known fact about ice storms is that just a quarter inch of ice accumulation can add about 500 pounds of weight to power lines, leading to widespread electrical outages. Ice storms underscore the importance of weather forecasting, emergency preparedness, and the resilience of infrastructure to withstand the unique challenges posed by ice accumulation. As weather patterns shift with climate change, understanding and planning for the impacts of ice storms is crucial for minimizing the risk to communities and infrastructure.